Question 10. Analysis of molecule X shows that it contains by mass 52% carbon, 13% hydrogen, and 35% oxygen. Because these are percentages by mass, we can assume that for every 100 grams of molecule X we have, 52 grams will be contributed by carbon, 13 grams by hydrogen, and 35 grams for oxygen. This is the ratio in terms of mass for 100 grams of molecule X. However, since the atomic mass of each element is different, it is only fair that we compare the relative abundance of CH and O based on the number of moles of the element present instead of the mass. To obtain the number of moles, we need to use the formula mass over the atomic mass. The mass in this case for carbon is 52 over the atomic mass of 12, 13 over 1 for hydrogen, and 35 over 16 for oxygen. The number of moles of CH and O will be 4.33 for carbon, 13 for hydrogen, and 2.1875 for oxygen. That means these are the number of moles of carbon, hydrogen, and oxygen present respectively in a molecule X. To get the most simplified ratio of all these values, we can divide it by the smallest value obtained, which is 2.1875. So taking 4.33 divided by 2.1875 will give us about 1.98, 5.94 for hydrogen, and 1 for oxygen. Rounding these values to the nearest whole number of 2, 6, and 1 for oxygen, we can conclude that for every 2 carbon atoms present, there will be 6 hydrogen atoms and 1 oxygen atom. This is the simplest ratio of each element present in a molecule of X. Knowing the simplest ratio can give us the empirical formula of molecule X. And we derive the ratio according to an assumption that there is only 100 grams of molecule X available. To determine the molecular formula of X, which means we need to know exactly how many carbon, hydrogen, and oxygen there is available, we need to have the exact molecular mass of molecule X. Therefore, the relative molecular mass of X must be available, leaving us with C as the correct answer because the only other information that we made use of was the atomic masses of carbon, hydrogen, and oxygen respectively.